Welcome back. So in our last video, we discussed adding polynomials. We're going to take it one step further today and learn how to subtract them. It's going to be very similar steps, but the very first step is what's going to be different. So our objective today is to subtract polynomials by first distributing the negative and then combining the like. Let's look at what that means. So if we look, we have 7x to the third plus 6x squared minus 2x minus the quantity 9x squared minus 4x plus 3. Once again, I made this sign in the middle a different color. That is how you tell if it's an addition problem or subtraction. The sign that is between the two polynomials. So once again, let's review our naming vocabulary. If we look at this first polynomial, it has a degree of 3 and it has 3 terms. So that is a cubic trinomial. If we look at our second polynomial, it has a degree of 2. The highest exponent is 2. That makes it quadratic. This one also has 3 terms, so it is a trinomial. So a quadratic trinomial. So we have a cubic trinomial minus a quadratic trinomial. Keep practicing that vocabulary. In a subtraction problem, we can't just drop the parentheses. If we do that, then we are changing the value of the problem. We don't want to change the value. We want to work through it and rearrange things. So to do that, we have to distribute the negative. And when I say the negative, that's this minus sign. We are going to distribute that to everything over there. That will allow us to get rid of the parentheses. So our steps to solving a subtraction problem with polynomials. Step 1, distribute the negative or the minus sign to every term in the polynomial to the right of it. So we'll multiply everything by the negative, or it's the same thing as -1 if that helps you to look at it that way. Once we do that, step 2 says we're going to combine all of our like terms like we did in addition. And then step 3, also like addition, make sure that we write our answer in standard form. So the only difference between addition and subtraction is that in subtraction, we have to distribute the negative first. Then we do the same things as addition. So let's go ahead and take a look at this problem. First step is distributing the negative. Again, if it makes it easier for you to think of multiplying by -1 when we're distributing, you can do that. You can even write a 1 in there if you would like. So here's my negative. I multiply it by this first. So -1 times 9x squared becomes -9x squared. Then I take it and multiply it by the next term. -1 times -4x. Negative times negative becomes positive 4x. -1 times 3 is -3. Essentially what we're doing when we distribute that minus, we are just changing the sign of everything to the right. That positive became negative, negative became positive, positive became negative. And then that gets rid of that minus sign. These are our new signs. From there, I can go ahead and bring down everything inside this first group. By distributing, we were able to get rid of the parentheses. So now that I have no parentheses, I can start looking to combine my like terms. So this problem I'm going to do with the method where we rewrite and put all of our like terms next to each other to combine them. So I have 7 to the I have no other x to the third terms, so I go to the next one. 6x squared, I will write that. Then I look for another x squared, there's one, -9x squared minus 9x squared. No other x squared, so I come back here, minus 2x. I look for a like term for 2x, well, 4x will do it, plus 4x. And the only thing I have left is minus 3. So now I rearranged and wrote my like terms next to each other. It might be a little easier to see to combine. So 7x to the third did not have a like term. That's going to come down the way that it is. Then I have my x squared terms. 6x squared minus 9x squared is negative 3x squared. Then I have negative 2x plus 4x is positive 2x. Negative 2 plus 4 is positive 2. And then I have minus 3 that has no like term. So I will bring that down. And then I want to check and make sure I'm in standard form. 7x to the third minus 3x squared plus 2x minus 3. So I have exponents of 3, 2, 1, and then 0. That is in standard form. Let's take a look at another problem. Again, subtraction, I know this because of this sign right there. So my first step is to distribute that minus to everything on the right. So negative times negative becomes positive 2x squared. Oops. Sorry, I leaned and it went to the next slide. Okay, so positive 2x squared, then negative 1 times negative 5x is positive 5x. Negative 1 times positive 4 becomes negative 4. Again, it's just changing the signs of each of these. Negative became positive, negative became positive, positive became negative. Once I do that, I can bring down my first polynomial group. And here again, let me rewrite putting my like terms together. So I can start with a 2x squared. Looking for a like term, there's a like term, another positive 2x squared. No other x squared, so I move to the next, minus 4x. Looking for a like term for x, there's one, plus 5x. Then I used that. No other x terms, so I come back, I have plus 4, the constant of 4. Keep looking, then I have a minus 4, also a constant. Then I used all my terms. So I'll look to combine. I have 2x squared plus 2x squared. 2 is 4x squared. Then I have negative 4x plus 5x. Negative 4 plus 5 is 1, positive. So you can put plus 1x, or you can just write plus x. And then I have positive 4 minus 4. 4 minus 4 is 0. I don't write plus 0. They eliminate each other. They go away. They disappear. So here's my answer. I need to check to see if it's in standard form. Exponent of 2, exponent of 1, greatest to least. So that is correct. My answer is in standard form. And let's try one more example. Once again, I'm looking at it. It is a subtraction problem, so I know I need to distribute the negative to everything in the polynomial to the right. So that becomes negative 15x and positive 4. And then I can bring down stuff in the first group. And for this one, I'm going to draw my shapes like I did when I showed you how to add polynomials. So 2x squared, square around that one. I don't have any other x squared, so that comes down the way that it is, nothing to combine it with. Then I have positive 11x, negative 15x, So 11 minus 15 is negative 4x. And then I have a constant of plus 4, nothing to combine that with. So I bring that down and I check to see if I'm in standard form. Well, I have an exponent of 2, an exponent of 1, and an exponent of 0 because there's no variable there. So that is also in standard form. So now that you know how to name polynomials, how to add them, how to subtract them, there's a Desmos activity. There's the link in Google Classroom. The post looks like this. The activity is worth 5 points. There's 5 slides that you need to do something on. 2 of them you need to drag steps in the correct order for solving a problem. There's one that you have to tell if a student is correct with their answer or not and why you need to support it. And then there's 2 that you're actually going to draw on the sketch pad and show your work on the screen and then type your answer in. So there's 1 point for every correct slide that you submit. You can resubmit this. So if you get less than 5 points when I give you your grade, I will tell you which slides were incorrect. You can go back into Desmos and fix those. But if you do that, you need to come back to this post and mark it as done. I'm not sure if the button is going to say done or resubmit or submit. You need to do that to alert me that you made corrections. And if you're not sure how to do that, it doesn't make any sense, then send me an email to let me know that you made the corrections, or I may not notice it, and then I can't give you those points if I didn't notice it. So, like I said about the quizzes, again, make sure that you are signing in using your student Google account and your first and last name. I don't want to overlook you because you called yourself Billy Bob and then I didn't know who that score belonged to. Okay? So you should be all set to finish that. See you next week, guys.